Hello everyone. Today I'm going to teach you how to create a program for the TI-nspire and how to solve double integrals and finding the mass and center of mass with the density function and double integrals. And we're going to build that in the TI-nspire. It's just simple, right? So we have this problem, alright, where we have limits, we have the density function, and we are asked to find the mass and the center of mass, alright? Right, so first we have three formulas. The first formula is for the mass. The thing we're going to do is just grab the density function and put that inside double integral. Alright, so usually the density function is represented by rho, but now in this problem we have the density function as lambda in terms of x and y. Alright, so this is a simple problem. You're gonna see why, but okay, so for the mass we grab that density function and take the double integral. As right here, this problem, we're gonna draw a graph. So if we take the limit here in this statement, we can see that x goes from -1 to 1, and right here in the limits, if we have the graph, we can set the -1 and 1 in x-axis, and then we can see that in the y-axis we are going from 0 to 1. Alright, so it's from 0 to 1 as this graph is showing, and then we can notice that this is a rectangle, right? At first sight we can see that the center of mass should be at the center of this rectangle, right? If it will be like a triangle or circle, it will change, but right now this is a perfect shape, so we can know that the center of mass is going to be at the middle of this rectangle, and also the center of mass respect to y and respect to z are going to change, right? For example, at first sight I can see that in the x-axis my center of mass is not changing. It's not going to the right or to the left, to the negative side or positive side, but in my y-axis it is changing, right? So originally my center of mass should be in the center of the graph, in the point 0, 0, right? But right now we can see that our rectangle is kind of up the x-axis, so it went like 0.5 units up, right? So we can already know that our result is going to be like, if we want the position of the center of mass respect to the x-axis is going to be 0, and with respect to the y-axis is going to be 0.5, right? Or 1/2. Okay, so let's find first the mass. So we grab the density function, it is x squared, as the problem is indicating, alright? And then just solve for that. Is pretty basic. Result is 2/3, alright? So that's the 2/3 is thing. Alright, so now for the center of mass, we have these formulas, but here is a catch. If we're going to find the center of mass with respect to x, we need to enter an x variable inside our function. Alright, and the same with respect to y. If we want to find the center of mass with respect to y, we need to set our function and then add a y variable multiplying that function. Alright, so it's gonna be like just like this. Okay, we have the x squared is our variable, and we are adding an x variable because we're finding the x with respect to x, and then multiplying everything by 3/2, that it will be like 1 over 2/3, but that's 3/2, and that's it. Just integrate, and then we're gonna get our x, our center of mass with respect of x is gonna be 0. The same with y, so we have this density function x squared, but we add this y in the middle of the function because we're trying to integrate with respect of y, and then just solve the integral, and we're gonna get 1/2. So that is what we originally thought about this. So we're gonna use this example to build our program in our calculator. Alright, so in the calculator I just ask for these variables with the prompt local. I added this x and y not because okay, it's simple. Just go to the calculator and control and this symbol library, and you can find the x, y not. Right. Okay, so we're asking in this problem for the limits that we're going to put in our integral, and then just fill basically the program that m equals to double integral our limits right here, a, b, c, and d, multiplying the lambda that is going to be our density function right here. So we're entering our density function in this prompt right here in the parentheses, and then the mass formula is just that, right? But when we're integrating for the center of mass, we're multiplying 1 over m. Alright, we already know m, and then the double integral, and we're multiplying the density function by the function we're trying to find, right? With respect of what? For example, right here I added an x because I'm integrating by x, right? With respect of x. And the same here, I'm multiplying by y because I am finding the center of mass with respect of y. Then just the display prompts, and that's it. So the results are going to look something like this. Not like this. Something like okay, let's try Control R, and then I'm gonna tell x squared. Alright, okay, it's gonna ask for my limits. Let's find the limit right here. Is from -1 to 1 and 0 to 1. Okay, from -1 to 1 and from 0 to 1. Alright, so that's my problem is solved. My mass is 2/3, respect of x is 0, and center of mass respect of y is 1/2. So we can use this program to solve our problems with basic shapes or parabolas or basic things. Okay, so that's basically it. That was all. Thank you so much, and see you next video. Thank you.